Hello class, welcome. We are getting into our next unit on geometry. Okay, we've been doing algebra topics this entire time, and now we're going to jump into geometry. We're still using some algebraic properties. We'll talk about that a little later when we talk about the actual rules of our what's called transformations. But right now we're going to get into the meat of geometry. And as we've talked about, we're going to discuss transformations. Okay, and we've described transformation as some type of change, right? Some type of, it might be a reflection, as we'll talk about. It might be a rotation. It might be a translation. Moving even further, after this unit, we'll talk about dilations. Okay? So, in this unit of transformations, today I want to introduce you to the three main ones we'll cover in this unit, and that is translations, rotations, and reflections. Okay? We've mentioned this briefly before, but we have translations, rotations, and reflections. Or another way that we described it in class was when we say translation, slide. When we say rotations, we say turn. When we say reflection, we say flip. Okay, so we're either going to slide the shape, we're going to turn the shape, or we're going to flip the shape. And I want to show you how those would look if we did this on a graph. Okay, so here I am on GeoGebra, and you could definitely log on to this as well and try these for yourself. I'm going to start out by first creating a shape, and it doesn't matter what the shape is because we're just going to show you the ways that we would transform it. So let me click over here on more, and I'm going to click on polygon. Okay, and I can click here. I'm just going to create four random sides. Okay, so we have a four-sided shape, four-sided polygon, or a quadrilateral. Let me show us how we would do that. Let me go up to transform. I'm going to do this, translate by vector. Okay, so first I'm going to click on my object. So I want to shift this from, and if I notice I want to shift it, a lot of times we'll hear make a translation 4 units to the right. Okay, well, I can look at any of these points, and I'm right here. Let's look at point C. Point C is at -3, 4. If I move it over 4 units to the right, it means I'm going to add 4 to the x value. So I'm going to move it over 1 unit, 2 units, 3 units, and 4 units. Let's see how that goes. And notice how here we then have the same shape, but again, it looks like it's just slid over to the right 4 spaces. And of course, very important to note as well is those shapes, or excuse me, those points, right, are A, not A anymore, it's A prime, B prime, C prime, and D prime. And as we're going to do right 2 spaces, right? And let's say we're going to go up, let's say 3 spaces, or 3 units, we should be saying, right? Okay, how do we do that? Well, exact same thing. And again, I'm going to show it here on GeoGebra. And as we do it, and I'll show you how to do this also on patty paper, just using a sheet or a sheet protector in the next upcoming videos. But just to show you how to do it, translate by vector. Let's click on the shape again. Let's go from here. We're going to go over 1, 2 to the right and up 3. 1, 2, and 3. Let's try it. And notice how everything shifts up 3 units and to the right 2 units. And again, we have our A prime, our B prime, and our C prime. All right, so that's, again, what we call a translation. Okay? Now, the next thing we want to do, we just did a slide. Now we want to do what's called a turn. We want to rotate. So it's as if we were to take the shape on the screen and we're just going to turn it. We're going to turn it, and as we're going to talk about a little bit later, normally when we say rotate, we generally are saying counterclockwise or turning to the left, right, as opposed to turning to the right. Okay, we mentioned that in some of our lessons, but again, we'll continue to discuss that moving forward. All right, so let me go here, and I'm going to reflect in this case, or I'm sorry, I'm going to rotate. Okay. Okay, in order for me to rotate, I'm going to have to put a point here for us to rotate along. So I'm going to put a point here at the origin. So when we rotate about the origin. We are technically rotating around a point. So let me click here, rotate around point. We're going to click here, and we're going to click on the actual point of the origin. Now, it'll ask us here, what kind of rotation do we want to make? So we mentioned this already, and we'll continue to mention this. When we talk about rotation, we will do it as generally a counterclockwise rotation. Okay? And normally we'll do what we call, if you remember from our first introductory lesson, a quarter turn, a half turn, a 3/4 turn, or a full turn. And if we're doing a quarter turn, we're going to do a 90-degree rotation. If we're doing a half turn, we're doing a 180-degree rotation, right? 180 degrees. If we're doing a 3/4 turn, we're going to do 270. And if we're doing a full turn, we're going to do 360 because we're rotating all the way around to be back in the original position. So actually, let me show you that right now. If I did 360, nothing would happen. And notice how now I have B prime, C prime, A prime, and D prime. It stays in the same spot because it shifted all the way around and then went back to its original spot. All right, so let's go again. Let's rotate. So I'm going to go down to transform. I'm going to go to rotate around a point. Let's click on our shape, and then we're going to click on this. And let's do, in general, what's called a quarter turn. So we're going to do a 90-degree rotation around the origin, counterclockwise. And what should we get? And there we get our turn. Notice how you can see it really looks like you just took, almost like if you can take this on a string and then just move it all the way down, right? As if the string kept it attached to the point and just moved it down in a quarter turn. Right? If we kept going, we would make a half turn, and then we would make a 3/4 turn. Okay, so that's, again, what we call a rotation. Let's look at one more. So let me clear screen. And finally, we'll talk about what's called a reflection. We said, right, a reflection is a flip. So imagine almost like it's a pancake or a burger. And we're going to flip over on the other side. And we always reflect across a line. We're going to reflect, in this case, across the X or the Y axis. So let me show you that. So let's click here on our shape. And I'm going to reflect across the Y axis, which means I'm going to look at that Y axis as the halfway point, right? Or almost like a fence that I'm jumping. Remember, we also mentioned that when we reflect, we're jumping over the fence. What fence are we jumping over? The Y axis. So if I click here, notice how that looks like a complete flip over into the other quadrant, right? We took our burger and then we flipped it on its side, and it looks like a mirror image, right? A reflection. When you hear that word reflection, you see your reflection in the mirror. Notice how it's almost a mirror image of the exact same shape. And it's a mirror image across what? Across the y-axis. Notice how it's the same number of units away from the origin. It's 3 units away here, and it's 3 units away here. Right? This is about 4 units away from the origin, and we're just talking about from the x values, right? From left to right. And this is also 4 units away from the origin, right? It's a complete flip and a complete reflection. If our mirror were the y-axis, notice how it's completely reflecting and looks and has the exact same distance from the y-axis. Okay? And so let me show you one more example of a reflection. We said that we can also reflect across the x-axis, which means x-axis, that horizontal line, is the fence that we're going to jump. We're going to flip over. Okay, so let me click again on reflect about a line, clicking on our object, and then we're going to click on the x-axis. And notice how, look at that, there's a complete flip, right? It's a little bit different. It's not the same, even though it looks kind of close to a rotation. It's not the same. And notice, I'll show you that also. Let's try that. Because you might say, oh, doesn't it look the same? I mean, it looks like it's in the same spot. Well, is it? It's in the same location, maybe, but if we do this rotation again, shapes don't look the same. They don't match up, right? So rotations and reflections are different. We need to keep that in mind. And it also just depends on which line we're doing it on. In this case, we reflected. The first reflection was across the y-axis. The second reflection was across the x-axis. And if I had it, if this was a physical piece of paper, I could literally fold it up in half, right, from either the y-axis or the x-axis, and they would touch, both shapes would touch each other at the exact same points because it's a real reflection. Okay? All right, class. So I hope that you enjoyed this video, and I hope this was much more visual for you rather than just the rules, which of course it's important for us to know the transformation rules, but also to be able to see this visually and why it is that we say we're translating, reflecting, or rotating, or as we like to call it, sliding, flipping, and turning. All right. Thanks for watching, guys. I will see you in the next video, and good luck on the independent practice.